So the next step is, well, once you have the data, how can you plot it? So you can see we're running just the single case. So this is not a parameter sweep. I can see the final velocity. It looks like I would expect, not moving next to the wall. It is moving near the panel, moving back and forth. We can do an animation of this, say that we just want to have it on the local player, and it will show how the velocity builds up. You can see over time, if you do all frames, instead of just a number of frames, then it will take a little bit longer. But we can again hit play, and you get something that's a little bit smoother. You can see it takes a while for it to build up. It starts fluctuating back and forth. It builds up, and now you're starting to see higher and higher velocities. And you can imagine a paddle on your left going back and forth and making those pressure changes. That all looks like you'd expect. You can do the same thing looking at the pressure. Instead of velocity, we can make a pressure animation. Right now, it would do it with lines, which is fine. We can do that. So if we do an animation with the player on this, and again, do all frames, then we can hit play. It'll take a while to assimilate all frames. And you can see the pressure starts to build up back and forth. If you want to make it color instead of contour, you can do that as well. You have to go to the pressure and say, make it color instead of contour. And there you can see all the pressure fluctuations. If you want to see how the pressure varies at your one data point, that is a 1D plot. So if we say under results, we want to do a 1D plot group, the plot group will now be a group of different lines on this particular plot. We're going to do a point graph. So we're going to do this particular point. There we go. We can plot velocity. That sounds good. Let's plot it, see what happens. There's our velocity, or we can plot pressure. Plot, and that looks not bad. You can see that it is coming a little bit smaller here at the top, so that's probably due to the fact that we didn't have a tighter mesh. So that would be something to play with, just like in the velocity. It's a little strange. I think I would probably increase my mesh size. But for the most part, it looks pretty good. If we want to test a different time, we can go to we can now create a parametric sweep and go across a lot of different times. We can also do a parametric sweep with just one other frequency and therefore test the parametric sweep as well. The last thing I like doing is using derived values. So we could also look at adding a new derived value for maybe the average along a line of the pressure along the far wall. So let's zoom in to get that far wall. And on that far wall, I might want the pressure. So I can do that and evaluate, and that gives me a table of time versus pressure, as you can see. Down here, that's table 1, so I can also do a 1D plot. So maybe we'll make this a second 1D plot, and we can call this table plot. And under that 1D plot, we will say we want a table graph. And I'll just say of table 1, and then hit plot. And there you have exactly this, or very similar, because our point is very close to that wall. So all of that looks good.